let's have a look at question 2. So this is clearly a pulley question, so force and motion. Let's have a look. A small stone A of mass 3m is attached to one end of the string. So it says the mass is 3m, so we know the weight would be 3mg. Now, as long as have contact, that would be a normal reaction, which is perpendicular to the plane. So then that would be a normal reaction R. And the small stone B of mass m is attached to the other end of the string. So the mass is m, that means the weight is equal to mg. And then that'll be a tension goes up, and then tension goes down, and then tension goes up, and then like this. So just make sure, so those two forces will act on the particle B, and then those forces should act on the particle A. And then the plane is inclined to the horizontal at an angle alpha, where tan alpha equal to 3/4. So if we sketch them out, so then this is alpha, so tan alpha equal to 3/4. So opposite has to be 3, adjacent has to be 4. That means hypotenuse is 5. So sine alpha is 3/5, and then cos alpha has to be 4/5. And the string passes over a pulley that is fixed at the top of the plane. The part of the string from A to P is parallel to the line of greatest slope of the plane. And then stone B hangs freely below P as shown in figure 1. The coefficient of friction between A and the plane is 1/6. And then stone A is released from rest and begin to move down the plane. So this says is moved down the plane. So that means the has to be accelerating downwards for A. And that means B has to be accelerating upwards because they are connected. So if A goes down, B has to be goes up. Yeah. Which also tell us a very important information. The friction should be opposite to the moving direction. If A goes down, the friction has to be opposite, which moves up. And then we know the coefficient of friction is 1/6. So that means the friction should just be R/6 because the friction is equal to mu R. So 1/6 times R, just R/6. And then we need to resolve all the forces either parallel to the moving direction or perpendicular to the moving direction. So for the force acts on A, R is perpendicular to the plane, so does the friction and tension. So only 3mg is what we need to resolve. So we just have to resolve it. One perpendicular to the moving direction, one parallel to the moving direction. So this is alpha. So that means this force is 3mg cos alpha. And then this one would be 3mg sine alpha. Okay, now let's start to do the question. It says, use the model for the motion of the system before B reaches the pulley, write down the equation of motion for A. So for part A, if we want the equation of the motion for A, it basically F equal ma. So force to the moving direction is just 3mg sine alpha. And then force opposite to the moving direction would be the friction, R/6, and also the tension. Then that's equal to mass times by acceleration. So 3m times by A. And then we know the other one, which is perpendicular to the moving direction. It just R goes up, and which equal to the one goes down. So 3mg cos alpha. So like this one is equal to this one. Up equal to down. And now we can start to simplify them. So that would be 3mg sine alpha, we already know is 3/5. And then minus R/6, we know, so let's just write as 1/6 R. So R is equal to 3mg cos alpha. And then we know cos is equal to 4/5. And then minus T we don't know, equal to 3ma. So if we simplify them, 3 times 3/5, that's 9/5 mg. And then minus, so 1/6 times 3 times by 4/5, which will give us 2 over 5 mg. And then minus T equal to 3 ma. So we can simplify those two because they are in terms of mg. Minus them, that will be 7 over 5 mg minus T equal to 3 ma. Okay, that would be the equation of motion for A. And then for part B, so B goes upwards. So force to the moving direction upwards, which is T, and then downwards it would be mg. That's equal to mass m times by acceleration. And then the other equation we have from part A would just be 7 over 5 mg minus T equal to 3 ma. To solve this simultaneous equation, we can just add them because this is positive T, this is negative T. If you plus them, it all cancels out. So T minus mg plus 7 over 5 mg minus T equal to ma plus 3 ma, that would be 4 ma. And then T minus T cancels out, that's what we want. And then negative mg plus 7 over 5 mg should just be 2 over 5 mg. Because negative 1 plus 7 over 5 is just 2 over 5. And that's equal to 4 ma. Divide m for both sides. And if we divide by 4 for both sides, 2 over 5 divided by 4, that's just 1 over 10. And then g is just g. Then we get a equal to 1 over 10 g. That would be the answer we want. And then part C is a sketch a velocity time graph for the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. Explain your answer. So they want a velocity time graph. So then this would be V, and then the horizontal axis would be time t. Because it starts from rest. So because when A released from rest, and then they connected by light and inextensible string. So that means they should have the same velocity. So if A start from 0, B should start from 0. So if we want to sketch the velocity time graph for the motion of B, so it has to be start from 0, 0. And then we know the gradient of the velocity time graph is equal to acceleration. And then we know acceleration is 1 over 10 g. So it's constant. So it has to be just a straight line, goes up. So it should be something like this. That's how we sketch them. Yeah. And then they want us to explain your answer. So we can say, so since A is released from rest, so that means AB has velocity 0 when t equal to 0. That's why we start from the origin. Yeah. And then also, this is the first point. And then for the second one, you can say the gradient of velocity time graph is acceleration. Since it is constant acceleration, 1 over 10 g, that means it has to be a straight line. And then part D. So in reality, the string is not light. D state how this would affect the walking in part B. So because if the string is not light, that means it will have weight. Yeah. And if the string has weight, so like if it's longer, then maybe that'd be heavier on this side, and this is shorter, that'll be light on that side. So that it just means the tension will be different. Yeah. You just say the tension on A and B would be different. because it's only 1 mark. That's all you have to say. Yeah.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.